All right, so today and a little bit of tomorrow, we're going to focus on MongoDB. MongoDB describes itself as a document database, and I'll explain what that means in a moment, with the scalability and flexibility that you want with the querying and indexing that you need. That's their little marketing message. There are certainly other types of databases that are common. I would say the next most common database, or probably the most common database, is SQL, SQL, pronounced SQL. And often we use the version called MySQL. That's very common. We're not going to focus on it in the context of this class. It has a steeper learning curve. It's a little bit more structured. They're just different approaches to storing data. We're going to stick with MongoDB because it's very accessible and very easy, yet we can do more advanced stuff with it as needed. So we need a couple of terms. So MongoDB is a general purpose document database. You can very much think about it as, well, here, let's define a couple of terms, and then I'm going to make an analogy here. So in MongoDB, we have a database, and a database contains collections. A collection contains documents. So three important terminologies here for MongoDB: database, collection, and documents. Here's my example. You can think of, let's make an analogy to Google Drive. We could say Google Drive is like a database, and Google Drive contains folders, which are like collections. And collections or folders contain documents. Okay, so you can very much think about this as Google Drive is your database. You have folders in Google Drive, just like we have collections in a MongoDB. And then inside of those collections and those folders are documents. That's the model. Much like you can put whatever you want in a Google document, you can put pretty much whatever you want in a MongoDB document as well. Everything that gets stored in a MongoDB document, though, is essentially JSON, really similar to JSON. And we'll look at different tools. We'll print things out. You'll see what it looks like as JSON. What's cool is that it's really easy to map our documents in MongoDB to objects in JavaScript. Okay, so they just show up as JavaScript objects. To help us keep track of things, every document requires an underscore ID field. That underscore ID field is a globally unique identifier. No two documents in any Mongo database in the entire world throughout time will ever have the same underscore ID field. It's of type object ID. Mongo has its own set of types, and we'll create mappings between those types and our JavaScript types. But that type is object ID, which is a little unique. It acts as what is called the primary key. We're not going to spend a lot of time on this, but in databases are efficient for searching based on certain keys, based on their primary keys. So it is very fast to find a document in a Mongo database when you have its ID. It is possible and just slower to search on anything else as well. So often we don't even think about the ID. It's generated automatically when we make a new document, so we don't need to do it ourselves. And if we do want to specify it in some way, we're welcome to do so. All right. The challenge, so I use this part of the unit, and I use MongoDB as our opportunity to introduce what are called promises. The theme, the challenge that we will struggle with throughout the rest of the year, including this unit, is really the flow of execution as we start writing web applications. And we saw a little bit about that with arrow functions in terms of we write this code for map, but it's not executed when the map is executed, it's executed later. After break, we're going to get into client-server web app architecture, and it gets confusing between what code runs on the client and what code runs on the server and when. And then the third challenge is this one here, the idea of a promise. okay? In JavaScript, this is not unique to Mongo. It just shows up here, and it's a very convenient place to talk about it. We can have objects that make promises. And I really like the name of this word. A promise is the idea that at some point in the future, I promise I'll do what you asked, but I'm not doing it now. So I'm going to give you a promise, like an IOU, and later that promise will turn into the data you asked for, the value you asked for, whatever it happens to be. Or if I couldn't do what you asked me to do, I'll tell you that too, and you can deal with it then. This is how we write asynchronous code. Asynchronous code means we ask for something, and then we go on doing other things, and eventually that something happens later. When we write web applications, writing asynchronous code is critical for a good user experience. Whenever we do an operation that can take a noticeable amount of time, we need to use a promise, okay? Whenever we query information from a database, that can be relatively slow, we use a promise. Whenever we fetch data from the server, when we start doing client-server stuff next week, that requires a promise. If we don't use promises, imagine the web app would freeze and it would be totally unresponsive while it waits for the database or it waits for the server. That would not be a good user experience. None of us like interacting with software that just freezes. All of this said, we rarely directly interact with promises, okay? But we need to understand how they work and when we use them so we can write code that leads to good user experiences. What we tend to do a lot of, or another key word in JavaScript is async. Whenever we have a function in our JavaScript code that is asynchronous, meaning it will return a promise, we need to put the async keyword before that function, either that function's name or the arrow function that we're defining. That's how JavaScript knows this function returns a promise, not a specific value, and JavaScript will automatically wrap all of that together in a promise for us, and know that even though this function says it returns an int, it really returns a promise that will be resolved to an int later. So you'll see a lot of use of async in our code to make it clear, like, this is an asynchronous function that returns a promise. There are times in our code where we can't go on until we get the answer to the function we called. We can't keep running stuff until we get the result of this database query or we hear back from the server. And the way we tell JavaScript, like, we need to wait is with the await keyword. You can only use an await keyword inside of an async function. We're going to see that. And what the await keyword does is it tells JavaScript, wait until this promise resolves and return its result instead. That means the code running in that function will be suspended. It stops running. And you might be saying, like, wait a minute, isn't the whole point of this that we don't want our code to stop running? To a degree, but when we do an await, that function stops running, but like our node server that's running our web app, it can do all sorts of other stuff. Everything else keeps running, just this function stops. So we can still be responsive to the user. It's not like the whole application freezes, but we need to be explicit and use await. So today you're going to see the use of async and await and promises, and we'll go through that stuff together. So let's take a look at, let's make this all more concrete because that's really, really abstract. All right. This is going to be cool. Ooh, I need to stop recording. All right. First things first, stop. All right. So we need to require something to interact with MongoDB. So this will be new to us. We're going to, basically this is like a Python import, which might be familiar, or a Java import. So we're going to import this thing called Mongo Client. And we're going to do that by using require. And the node module we are requiring is called MongoDB. It's the module that lets us interact with the Mongo database. we are going to also do something that we'll do throughout the rest of the year. We're going to load what are called environment variables from the .env file that we just created. And we're going to load them into what's called process.env, which is part of our our environment that we can reference throughout this whole file. So first, there's another module we need called .env. So we're going to do another require, and we're going to require .env. Now that we've basically imported this and assigned it to a variable, we can call the config method on it. And we're going to tell it where our environment variables are stored, and they're stored in the file .env that we just created. Now we can have a lot of different things in that .env file. Today we just have our Mongo credentials, but we can have a lot of stuff. So now we can actually make a connection to our client. I'm going to make a new variable called client, and I'm going to create a new Mongo client because we imported Mongo up here. That takes one parameter, which is the URI or the URL. And as I said in the comment, that's now stored in process.env. And then the name of the property we used that we copied and pasted is Mongo URI. The code we're going to write, mostly tomorrow, is asynchronous. And so we can't just type it in the file like we have with the other files we've been doing. We have to put it inside a function that's asynchronous. So we're going to say async function run. I'm just calling my function run because I need a name for it. And then I'm going to put all the code in here instead. And then later we'll call this function and JavaScript will know that it's asynchronous. Things might go wrong. We might not be able to connect to the database. Our credentials might be wrong. So we're going to wrap all of this in a try-catch block, much like we would do with a Java exceptions. And the first thing we need to do is connect to the database. And we're going to say await client.connect. We're going to call the connect method on the client object we created. This is connect is an asynchronous function. It takes some time to make a connection to the database. We can't do anything else productive until we are connected to the database. So I'm going to put the await keyword here, which says, tells JavaScript, wait for the promise returned by the connect function to be resolved before moving on. Other code, other threads can keep running, but this function will be suspended. All right, we'll just grab a couple more things for today. We're going to obtain references to a database. That's one of our new pieces of vocabulary, and one of its collections. Remember, databases have collections, collections have documents. So I'll create a variable called DB, which will reference our database. And the credentials I gave you refers to a database that's already populated with some data about the planets. And that's what your lab practicum is about. Oh, I misread the time. We're going to stop right there. We'll get this all up and running tomorrow. It'll be great.